Good morning, good afternoon, and good evening, everyone, depending on where in the world you're joining us today. I'm pleased to present today's webinar, The Art of Catching and Investigating Data Exfiltration. This will be a best practice use case leveraging both Plixer and Endace technology. To introduce to you the voices that you'll be hearing, my name is Bob Noel. I am the Director of Strategic Partnerships and Marketing here at Plixer. I am joined by Carrie Wright. Carrie is Vice President of Product Management at Endace. And I'm also joined by Thomas Poor, who is the Director of Information Technology and Services. During today's webinar, we will be talking about data exfiltration specifically as the use case that we will address, and the challenges of identifying and catching data exfiltration as it's taking place. We'll be taking a look at Plixer and Endace and giving you an overview from a company perspective, giving you a bit of background, and then we'll transition fairly quickly into the use case itself. We'll do a live demo. We'll show you how to find a breach, reconstruct the data, and that's important to ensure that you're able to notify the right people regarding the information that may have been taken as it pertains to account information and personally identifiable information. We'll wrap it up and then we'll move directly into a Q&A. So the point here of this slide is that there are brands all over the world, large brands that have invested significant sums of money into their security infrastructure, yet they've experienced a breach. And this is worldwide. It's growing. We'll actually talk about the rate of growth of these things occurring, and it's very costly. In fact, specifically as it pertains to Target, Target breach occurred in 2014, and to date, not just the upfront cost, which was about $162 million, but over time, it's come to be nearly $1 billion in total cost to the brand. So these things are costly. Now, according to the Identity Theft Resource Center, the trajectory of data breaches is growing. And what's interesting about this particular slide is that other than hacking, right, other than hacking and skimming and phishing, all other mechanisms for data theft and data breaches are going down. But you can see that very specifically and very dramatically, the growth in this idea of cybersecurity, hacking of information. And for the last 8 years in a row, that has been the leading cause of these data breaches, and it accounts for more than half of the overall breaches that occur on a global basis. Now, if you consider the cost of these global breaches, right, it's massive. There are estimates that show with $450 billion in 2016 in terms of the global economy. The average cost of a breach is, according to the Ponemon Institute, about $4 million, and the likelihood that an organization will experience a breach in excess of 10,000 records is essentially 1 in 4 over the next 24 months. So every one of you, this is top of mind, it's real, and it is something that you're facing today, and the amount of time that it takes to identify is directly relational to the cost that you incur. And again, that comes from the Ponemon Institute. Now, the real challenge, so not only is it expensive, right, but it's very, very hard to catch. The initial breach, oftentimes the foothold that the cyber criminal gains, they only need a small foothold. They, again, use hacking technologies. They use phishing to gain access to credentials, but that initial foothold, that initial breach is oftentimes buried in an avalanche of tens or hundreds of thousands of syslog events, and you may not actually recognize that or see that. Now, the other part that makes it very difficult to catch is that the data is exfiltrated. It leaves your organization, typically over protocols and applications that you normally use in your organization. So, right, that traffic in many cases looks normal. And for the sake of not being caught, the bad guys typically exfiltrate or take that data from your network in a method that's low and slow, right? Very small rates, occasionally being sent off the network to keep it low under the radar and to keep you from seeing and catching that. So those are the challenges, right? It costs a lot of money. It's happening pervasively. It's very, very hard to catch. So now let's talk a little bit about how you can, in fact, identify these breaches, catch these breaches, and rebuild the data to know exactly what happened. So I'm going to transition now and talk a little bit about Plixer as an organization. Plixer was founded in 1999. We are not a startup technology. We have a very mature technology. We have thousands of global customers spread across 88 different countries. We are headquartered in the northeast of the U.S., about an hour north of Boston, in a town called Kennebunk, Maine, and we are a privately held organization. To try and visualize sort of the product that we are bringing to market here that helps you identify data exfiltration, product is Scrutinizer. Scrutinizer is deployed as a transparent technology on the network. It is deployed passively, and it is gathering information from the existing network that you have. It is gathering flow and metadata data elements from your Wi-Fi edge through your wired distribution and data center to your border router into the software-defined WAN, for example, or into the cloud. So Scrutinizer is gathering data about every conversation that is traversing your network. It's storing that data, and it's putting it in a place that enables you to access that to do incident response and forensic investigation. Scrutinizer delivers security analytics. So these thousands of data elements that we are gathering and storing about every conversation on your network, this data has security algorithms that are run against that, right? Behavior analysis is run to look for and uncover malware, ransomware, these low and slow data theft attacks, distributed denial of service, and such. The information that you need to deliver accurate and rapid incident response, the contextual data that is gathered from these thousands of data elements from the entirety of your existing network, right? It enables you to reduce the time from compromise, again, that initial foothold, to being able to root cause and resolve the problem. And as you'll see in the demo, right, the connection point and the integration with Endace is an important part of that. The forensic data is really about delivering the data you need when you need it most. Having a database that gives you access to the information about what happened. Being able to gather thousands of data elements across NetFlow and IPFix, and then pivot on any of those data points, and again, to show you rapid root cause and pivot directly into the packets that Endace is going to help us with. There's a tremendous degree and variety of advanced reporting capabilities in this product. Third-party vendor exports, proprietary type exports, and technology-related exports give you tremendous value. With that, now I'd like to hand it over to Carrie, so Carrie can introduce you to Endace.
Thanks, Bob, and glad to be on this call with you. A little bit about Endace. We've been in the market for over 15 years, providing platforms to industry for 100% network recording. We're protecting and helping the performance of some of the world's biggest networks and data centers. We've supplied solutions to telcos, the banking industry, the financial trading industry, many of the Fortune 50, large enterprise, government, military. Our solutions are not just a recording platform, but they're an open platform for hosting analytics applications and integrating with your workflow. Most importantly, our solution records every packet transaction at line rate with 0 packet loss. And we record that on disk on the system. That traffic can also be streamed to analytics applications which can be hosted on the platform. This is an open platform. Think of it as a virtualization environment where you can host different applications. We can stream that live traffic directed to the tools for real-time analysis. But what's more interesting is we can take that historical packet capture and also stream it to that virtual environment. So it's a playback environment for analyzing recorded events with any tool of choice. We also have a rich API that integrates with your chosen tool to help speed the workflow. So you can see it's a rich platform, not just recording, but an ecosystem that you can surround with your tools of choice. Typically, we distribute these monitoring probes, what we call the Endace probes, through critical points in your network. Anywhere where you need to monitor, say, the militarized zone, a branch office, all the way through to the core data center, maybe a sensitive server farm, etc. But these are some of the places where companies have deployed our solution. And then on top of that, because it's an open platform, you've now got the ability to distribute any of your tools of choice to the places where you've already deployed that Endace probe. So a very flexible and beneficial solution. Deploy the probe once and then choose which applications you want to deploy on demand out into your network. And lastly, a key part of our solution is the ability to scale. Some customers need monitoring of more than 1,000 network monitoring points, and may have large branch office deployments or very large data centers. And we provide the ability to manage an estate of probes that scales beyond 1,000, and then provide tools for NetOps or security operations team or DevOps teams to access the data across the fabric of network recorders. So a little bit about the demonstration that you'll see today and the integrated workflow that Plixer and Endace have created together. Firstly, I'll describe the scenario. Endace probes would be in place, recording traffic and potentially generating net flow records. These would be in place in your network and distributed around. Scrutinizer would be analyzing the net flow, collecting it, and other information across your network. If Scrutinizer raises an alert, the user has access to drill into that alert and look at some of the details. And then furthermore, the user will be able to then go from the alert directly into the packets of interest on the Endace probe. So there's a very quick and easy way to get from suspicious looking alerts to the actual data, the real packets, the actual information that may have been leaked, or the source of the security attack. So with that, I'm going to hand over to Tom, who's actually going to start walking you through a demo. And you'll find it fairly interesting. So I'll hand over to Tom now.
All right, so as Terry stated, we're going to jump into a demo, and we're going to show you how to use Scrutinizer to perform an investigation and then drop packets out of the interface. When we refreeze that, we'll pivot to Vision. Using Endace packet capture, we'll pivot into Vision, and we'll be able to extract packets and then look at them, and hopefully we'll be able to identify any data leak or data loss. So when I come into Scrutinizer, there's a few main views that people like to use. the status tab over here gives us a general idea of bandwidth consumption across our infrastructure. We have our devices, our interfaces, descriptions and bandwidth in and out. And so Scrutinizer is reporting on all the net flow collected across the entire enterprise. It gives us the source and destination IP address, ports involved, how much traffic's passed, the amount of packets. And once we have this type of visibility, Scrutinizer then runs behavioral algorithms across the data to detect anomalies that maybe detect anomalies with the traffic behavior, identifying potential threats that made it through your traditional IDS or ITS. So from a security analyst point of view, we're going to live in the alarms. We have a lot of alarms here. We see a lot of red and yellow. We see indicator correlation event. We see DNS data leak. We see rogue SMTP, rogue FTP. And an analyst may start asking questions, well, where do I even start? And so from the policy perspective, I can filter just on security events. These security events are incidents that need immediate attention. They're not necessarily one-off indicators of compromise. In this case, we have a correlation event, we have a DNS data leak, and then we have a Tor connection. The other perspective a SOC analyst can take is from the violator perspective. And they can filter and say, all right, well, show me my top violators across all my policies. At this point, they're displayed with a heat map, and we're presented with a few top violators. In this case, 10.1.15.19 is high and to the right within this heat map, indicating that this is a problematic asset that needs some investigation. I can come in and I can look at the policies associated to this. I see indicator correlation event. I see a Tor connection. So what I can do is I can come in and I can pivot into the correlation event, and then I see it violating a data leak as well as rogue FTP, rogue SMTP. So what I want to do is I want to start getting some eyes on the data itself. So from here, what I'll do is I will search for all alarms for this particular host. And I see our correlation event. I see a threat index threshold violation, which we know this is violating. But then I get down to the rogue FTP traffic. So I see some FTP out to an Amazon, essentially an EC2 instance here. So what I want to do is I want to identify what data left this particular internal asset and move FTP. Now, whether or not this was a data leak or maybe this was malware beaconing, well, let's find out. So from here, I can run a default report and get some eyes on the traffic itself, and I identify this in a pair relationship. And from the interface here, I can drop to other options and pivot to vision. And what this does is this is the integration between Scrutinizer and Endace that allows us to gain visibility into the packets themselves. NetFlow allowing you to perform that quick search across your infrastructure, getting to the conversation that you're interested in, and then from here we're able to put it right into vision and then focus on that particular conversation. All right, Carrie, now that we're in this vision, and we're focused on the conversation in question, do you think that we're able to drop the packets out of this web interface, maybe see if we can extract a file or identify the FTP traffic in question here?
I think we sure can, Tom. We can get to the bottom of this and figure out what was actually inside that data exfiltration thing. So let's have a look. We've got the investigation tool from Endace up here. I've arranged the tools here so that we can see them side by side. We've got a conversations tool with a traffic breakdown, a bandwidth tool, pop talkers tool. You scroll down a little so you can see those. The traffic breakdown gives you the ability to look at by protocol or by IP address. The top talkers, we've only got 2 here because fortunately, amongst the terabytes of data that we've stored, fortunately, Plixer Scrutinizer has handed a filter across to the Endace Vision tool so that we're going in with that razor sharp focus on the conversations of interest. So you can see the conversation of interest is this particular one here, with the .19 address was the one we were most concerned about. And what else we can do is we can bring this up in our onboard packets viewer and take a quick look to see some evidence and some detail of what's going on here. You can see, this is a pretty standard looking Wireshark view. Wireshark dissectors. You can start to see TCP or an FTP. We've got, let's see, user Sammy doing a FTP session with passwords, steal the data, looks suspicious. Oh dear, here we go. We're actually doing a store customer data, .xls. Now there's another way we can look at this. We can actually go back to the investigation. We can export this as a PCAP and also use Wireshark on our desktop if we want to dig in even deeper. So I'm going to do that right now. I'm going to download that as a PCAP file and then open it up in Wireshark. So here we are. We have the data pulled up in Wireshark. You can see all of those same transactions there. User Sammy, steal the data password, XLS X file. Because we know it's Excel, let's search for the magic number that's the start of the Excel file. I know that's string of hex digits here. So make the display filter, search on hex value. I will find that one. So I'm going to follow this TCP FTP stream and extract the data to an Excel file. You can see we need to change it to raw, so we save it as a binary. We're going to give it a name with an XLSX extension so that we can open it up. And hopefully we'll see what was actually exfiltrated. Let's have a look at this file. Oh, this is looking a little suspicious. Oh no, this is definitely not something we want to let out of the building. Very glad we caught this one. Okay, so hopefully you can see how easy it is to go from investigation right to the data that was leaked using the Endace and Plixer solution together. And that concludes the demo. So let's summarize. Data exfiltration is very costly to brand and business. It's becoming more rampant and it's very hard to identify. NetFlow and metadata can help detect the data exfiltration, and packet analysis can help you reconstruct that data to find out exactly what was lost. So using our combined solution, businesses can quickly, efficiently, and accurately remediate and notify appropriately. And this is becoming more and more important these days with the expectations of the market and the new regulations coming in. With that, I'm going to hand over to Bob to close out and start our Q&A session.
Great, thank you, Kerry. I appreciate that very much. Tom and Kerry, both well done on that demo. again, I'd like to just reiterate that one of the important parts of what you just saw in the integrated capabilities of Endace and Plixer is not only the ability to identify that data exfiltration is occurring, but probably more importantly, to be able to identify very specifically what data was taken. In a compliance world where we are, in many cases, required to notify customers and end users that their data has been breached, account information, their personally identifiable information, it's incredibly important to be able to understand what exactly was taken. You want to be able to know, do I need to notify 10 people or do I need to notify 10 million people? Quite frankly, the impact to your brand and the cost of these breaches can be directly related to that type of required response. So with that, let's take a quick look at what questions have come in.
Okay, so as I look here, there's actually quite a few. I'll take the first question here, which is more on the go-to-market and how do you, so the question was, how do I engage to learn more? Plixer and Endace are fusion partners, which means we're going to market with this joint solution together. The best way to engage is to reach out to either side. So if you're a customer or you receive this invitation from Endace, please reach out to them and they'll pull in the appropriate Plixer contacts. And the flip is also true. So you can reach out to Plixer first if we are your normal point of contact, and we'll make sure we engage the right resources to help you. Second question is that, Carrie, this one's actually going to be for you. It says, how do you find the packets quickly when you're recording from multiple points across the network?
Yeah, good question, Bob. There could be hundreds of terabytes of data spread across your network if you've got multiple probes. So there's probably a couple of points to this answer. Firstly, the workflow that we have between Plixer and Endace, the integrations help you get to the exact packets, the 10, 12 packets of interest very quickly because of the preform filter. But we also have the ability to create a hierarchy of probes. We have an investigation manager element that you can use to search across multiple probes in parallel. So yes, we can help you get to that data, those 10, 12 packets of interest very quickly using this architecture.
Great. Thank you, Carrie. Tom, this one's, I think, going to be directed to you. It says, Tom, you talked about catching data exfiltration with an alarm that was triggered, at least in the demo here, by rogue FTP traffic, but there are lots of ways that bad guys get data off a network. Question is, are there other mechanisms that we support to catch data exfiltration?
Yeah, there are a number. So we are watching for anomalies within the traffic reported as NetFlow, and we're looking for exfiltration techniques and tunneling. We demonstrated, essentially rogue FTP, but there's a number of rogue protocols that are common with data theft. ITP and DNS tunneling is very common, and we have that detection capability. And then at a broader scope, we have alarms for long flow detection. So for low and slow data exfiltration, as well as a data leak algorithm that's looking at a ratio of traffic. So how much traffic is leaving versus how much is coming in for any one conversation.
Awesome. Thanks, Tom. So Carrie, actually, I think this is probably going to be for both, but Carrie, I'll pose it to you first. How much network history can people keep, and how far can they go back for the Endace probe?
Yeah, good question. So that's also related to another one I see. What rates can we capture at? And they're kind of related. So we can capture anything up to 100 gigabits per second link. So whether it's 1 gig, 10 gig, 100 gig, etc. Typically we see customers trying to keep at least a week and aiming for a month's worth of data. With the Endace solution, you get the ability to scale that up so that you can store as much data as you can afford to provision in your network, and that helps you definitely with your investigations. Being able to go back to the packet data 3 or 4 weeks ago is often very important.
Great. So Tom, let me pose the same question to you when it comes to storing the net flow and metadata.
Yeah, so my answer is going to be similar to Carrie in that, disk is cheap, and we can store as much history as required. We don't have a limitation, and we can collect at the millions of flows per second. And since it's not raw packets like Endace is dealing with, given the same amount of storage, we would be able to retain significantly longer trending volumes.
Great. So I think the end result is, I think the question for anyone who asks that is, how long are you looking for, and then what's the storage requirement of that? So that's what tends to drive it.
Right. Are they meeting an SLA?
Right. So, okay. Thanks, guys. One more question. Looks like we've probably got time for one more here. And Tom, this one's for you. It says, if I already have Endace doing packet capture, do I still need NetFlow visibility, and if so, why?
Yeah, so this is, I'm going to piggyback Carrie's response from later in that NetFlow allows for extremely fast searching across a volume of traffic. In addition to that, Scrutinizer is performing behavioral analysis of that traffic to identify anomalies. And essentially, how quickly can you find a needle in a needle stack, right? And so if I already have Endace, implementing Scrutinizer on my network is simply going to allow me to complete my investigation, my search, much more rapidly. There's only 2 ways to obtain visibility within a network, NetFlow or IPFix collection through Scrutinizer, and then we have Endace with packets, and these solutions complement each other.
Okay, great. Well, thank you, everyone. I'm looking at the clock. We ran a couple minutes over, but those were good questions. I think worthwhile taking the extra time to answer those. And I'd like to once again thank everybody for your time and attention today. As you again can see on this last slide, if you have a question, please feel free to reach out via email to either of those, and we will be sure to get right back to you. So with that, thank you, Tom. Thank you, Carrie, and I'll let everybody get back to their day. Have a good one.